Hello and welcome to Module 16. So today we are going to talk about attacking the foundation. So we're specifically going to talk about the IP and the TCP and UDP protocol and see how they are vulnerable. So we'll cover three sections: the IP PDU, the packet itself and all the labels that are on it, and we'll look at the vulnerabilities, the different types of attacks that can be used using the IP packets and so on. All right, so let's remember to take notes. I'm going to ask you to take notes, so make sure that you have your Microsoft Word document ready. All right, so IPv6 and IPv4, both of them, the packets are connectionless. So please write that first statement down, and the second, actually write all three. I keep saying the 3 bullet points, so you'll know why IPv4 or IPv6 packets are really vulnerable. They're connectionless, and what that means, they do not make a connection. The three-way handshaking between the source and the destination is not done with packet 3. They rely on someone else to do that. That's number one. And they don't really check to see who is sending the data for them. They don't check the source at all. So to verify that the source is sending them this data, because it's connectionless and you don't verify who's knocking on your door, you just let them in regardless of who that person is. You can easily use that as an attack. And here are the labels for IPv4. Okay, so it's definitely a good idea to be familiar with all of these labels. Well, let's take a look at each one of those and discuss them. Okay. So, for example, the version tells you it's either you are version 4 or version 6. So if that 4-bit on the IPv6 on an IPv4 packet is 011, you know it's an IPv4 packet that's inside. That's an IPv4 packet, so that the routers will process the data according to the IPv4 protocol. The internet header is all 20 bytes. The label that says DS, this is mainly for quality of service, just to, depending on the number in there, it will say either you have priority to move the data if there's traffic or not. The total length tells you the total length of the data that's inside. The maximum is 65,535 bytes. Okay. The flags identify if the data, the fragment offset or flag, this is to identify if the data has been broken down into pieces. Okay. So let me just, sorry about that. Let me just go back a little bit. I want to be able to discuss these. And please, you know what? Take a picture of these from here, because you should be familiar too. So take a picture of this. Take a picture of this as well. So again, the flag is to indicate that the packet has been broken down into little pieces. The TTL number, this is a number that is placed on the packet before it leaves, and every time it goes through a hop, it's decremented to 0. If as the packet traverses the network, it goes from one router to another hop, and it keeps decrementing. The TTL number keeps decrementing. If it reaches a router and that packet has a TTL1, so when it reaches that router, that last router, it decrements it to 0, the TTL number now is 0. Then that router or that hop will not route the packet anymore. His responsibility is to use an ICMP. The router will create an ICMP reply to the source to tell them that your time has exceeded. You'll get if you're pinging, you'll get a label that says timed out, right? So the TTL number is to make sure that the packet reaches the destination with a certain amount of time. Otherwise, it'll get killed. Protocol is to identify the data that's inside the packet. If it's 1, that means it's an ICMP. If it's 6, it's a TCP packet. It's a TCP segment that's inside the packet. And if it's 17, that means it's a UDP. Okay, take a picture of this as well. The header checksum is to verify that the packet is good, right? Just to make sure. We know that the source IPv4 packet address, you get that from the DHCP server. The IPv6 address is IPv4 address, destination address. You get that from the DNS server. And the options and padding, it all depends. It's either between 0 and 32. And if zeros are added, this is just to make sure. Sometimes we add zeros up to 32 just to make sure that you have a 32-bit number. All right, so again, this will be a good example to look at the Wireshark. This is a good video to take a look at it. You'll have a good exercise on how to use Wireshark and be able to see and view. It's a good demonstration of how the headers in IPv4 and what they are live using Wireshark. Remember, Wireshark is the sniffer. Okay, so here's an IPv6 packet. Simplified and less labels are stamped on it. And that's why one of the reasons IPv6 makes it more, it's better to use. There are less labels to check if you are a router, right? So moves the packet much quicker. Again, let's take a screenshot of this. The version is to identify it's a version 6, so you'll have in there the 011. The traffic class, this is equivalent to the quality of service DS in IPv4, so depending on the number that's in there, it will tell the packet to either expedite the packet if there's traffic or not. Flow label, this is a 20-bit field that's going to it does the same, all the packets with the same flow receiving types of handling by the routers. So the flow label and the traffic class go together to get the packet moving as quickly as possible, depending on what that number that's in there. The payload link, this tells you what type of data that's in there. The header next is the 8-bit field equivalent to the protocol field to tell you what indicates the data payload. This tells you the length of the packet that's in there, and this tells you what type of data that's in there. Data, what I'm talking about is segments, right? That comes from layer 4. Hop limit is exactly equivalent to the TTL number, the time to live. So it's always decremented by 1. Again, if it doesn't reach the destination by that time, then the packet is dead, and then the destination will send an ICMP packet back telling you that time has exceeded, right? And then you get the source IPv6 and the destination IPv6 addresses. All right, so let's move on. Again, please take a look at the Wireshark video again for IPv6 again. All right, so this is also a good demonstration that you should take a look at. Now, let's take a look at the IP vulnerabilities and the different types of attacks that are in there. Take a snapshot of this. Okay, you need to know these definitely because they always will come up on either on the classic, the chapter exams, or even on the CyberOps associate test. ICMP attacks. ICMP is mainly used, the Internet Control Messaging Protocol is used for really management of the whole internet. And part of the ICMP, we use the ping command, the echo request, and the echo reply. So we may generate a lot of pings, ping of death. So we may use the ICMP protocol to overwhelm and do a denial of service attack on the victim on the destination. Okay, that's a denial of service attack. We may use a distributed denial of service attack where we can have millions of controlled zombies, we called. I know we discussed this before, from different devices send requests to the victim, and the victim will be way overwhelmed and will not be able to process the data. Address spoofing. Okay, so we may spoof the source IP address. Why do you want to pretend to have someone else's source IP address? Well, maybe that's why you can go through a firewall because of that. Okay, and so you may change or maybe you want to hide yourself. You don't want to be known where the attack came from. So you may spoof the source IP address. Man-in-the-middle attack is you using Wireshark or using a tap or anything in between, so you can watch the data as it traverses the network. Data will go through your device, you'll look at it, and you'll relay it to the destination. The source and the destination won't even know that this is actually happening. Okay, so that's the man-in-the-middle attack. Session hijacking is if someone already has a legitimate connection to the destination, you can go in there and actually use that open session to send data to the destination. You can't receive though, but you can create an attack that way. That's called a session hijacking. You're taking over a connection that's already in place. All right, so here's an ICMP attack. So like I said to you earlier, ICMP was developed to carry diagnostic messages. This is really like the manager to let you know what's going on the network. Send error reports and things like that. So you can use a ping command. Just keep sending echo requests using someone else's IP address, for example. And you, as a victim, by default have to respond, echo reply. So, but if I can use millions of people keep sending you pings, imagine that. There's a lab where we can do that in class. And if you keep sending it and you just write a little script that keeps sending pings, and this guy, the victim, not knowingly what's going on, he keeps replying him back. So that is called ping of death. You can actually create that. That's a denial of service attack. Okay, so take a snapshot of this. So let's take a look at, these are the different common messages that ICMP uses. So a hacker or a threat actor may use these to attack. So an echo request is the ping. An echo reply is the reply from that ping. So we may use that to create a denial of service attack. ICMP unreachable. This is a message that you get if the network is not there, right? So you may do a ping sweep. And when you get network unreachable, then you know those devices don't exist. So you don't even bother attacking. So you got to do that right. Reconnaissance. So you may use the ICMP to do that. ICMP mask reply. This is going to map the internal network. So you may actually see how the whole network and who is there in the internal network and what IP addresses in there. So you can map the whole internal network, and you can actually see paths on how to get to your victim. ICMP redirect this is used to lure target hosts into sending all traffic to you. So instead of sending the data to, for example, to the default gateway, you can redirect it to you. Router discovery. So you can actually tell the routing table that you have, change the routing table routes, right? You could do that. All right. Let's take a look also now at something called amplification and reflection attack. So please write these two bullet points down. Amplification and reflection, you need to know what they are. So amplification meaning that you can have, let's say I will send, using this guy's IP address, ping commands. That's called a Smurf attack, by the way. And I will ping everybody. And what is everybody going to do? Reply to the victim. The poor guy is going to be overwhelmed. He didn't even do any pinging. That's called amplification, right? So, and reflection is when they reply. So when the threat actor sends a ping command to many hosts containing this guy's IP address, right? That's the amplification. And when they reply, that's the reflection. And this guy gets overwhelmed with it, right? All right, address spoofing. Again, using someone else's IP address to launch an attack. What is that? You can do that. Please write that down, the spoofing. Spoofing meaning pretending to be someone else, using someone else's source IP address. Why do you want to do that? Either to hide yourself so nobody knows that you are the one who was launching the attack, or just to create a denial of service attack. Either or, it doesn't matter. It's still an attack. So you can either do it non-blind and blind. You need to know the difference. So please write these two down. The spoofing attacks can be non-blind, meaning that you don't see the data that's being sent back. You're just creating it for denial of service attack. So that's what we just discussed earlier. When you have the amplification and reflection, you don't care about the data that's being sent back and forth between the those computers and the victim, right? That's blind, actually, right? That's blind spoofing. You just want to create a denial of service attack. Non-blind is you spoofing, you're pretending to be somebody else's, but they're sending the data to you now because you're the source and you want to be able to see the data. That's blind spoofing, right? You're doing it for the reason that because you want to receive the data that is meant for the victim, right? That's non-blind spoofing. Address spoofing could also be done at the MAC sub layer. At the data link layer, right? So if the switch has, for example, the server MAC address is located at port 1, I can just send, and I know the MAC address of the server, then I'll tell the switch, hey, I am the server. My MAC address, ABBCC, you send the frame to it, and because the switch by default inspect the source IP address, and this guy has spoofed it, stole it from here, pretended to be the server, then the switch will say, okay, now the server is no longer located at port 1, it's going to be located at port 2. He doesn't know. He just inspects the incoming frames. And now all the data that is being sent to the server, the switch will send it to you because he thinks you are the server now, right? That's attacking the MAC address table. And you can actually do that with the, what was I going to say? With the DHCP server as well. Well, we'll talk about that some other time. All right, now, if we move up to the layer 4, the transport layer, we got TCP and UDP. So let's take a look at the labels, the header, we call it, right? The labels that are stamped on the data that came from the application layer. So all these labels with the data that came from the application layer, that's what creates the segment, the TCP segment. And the header is 20 bytes, and there's a lot of labels in there. The control bits is what you can actually use to create, to have a connection-oriented, the session connection, to keep track of the packets that are being sent. So the control bits, it's a 6-bit number. You can either have an urgent acknowledgement, the push, the reset, the sync. You may reset the packet. You may create a synchronize, or you can send a bit in here to say, hey, we're not sending any more data. That's the fin, right? This is where you do the synchronize with the packet, with the destination. All right, reset the connection. So you can use that as an attack to reset the connection. All right. So please take a picture of that before I forget. So do take a picture of this. So TCP is a reliable delivery. Please write these three statements down. I know we did them. And let me just explain this again. TCP is reliable, meaning it's going to make sure that the data has been reached and it reached successfully. That's what reliable means. Flow control, remember we're using windowing to the receiver will always tell the sender to either increase or decrease the amount of data that's being transferred using the windowing technique, right? So we control the flow of data. Either we can increase or decrease the amount of segments that is being transmitted. Stateful communication, meaning that we are going to make a connection. This is connection oriented, the three-way handshaking technique that is being used to create a connection before you send data, right? All right. So here's the three-way handshaking technique. I know we've discussed this before, but the three-way handshaking says before you send any segment out, if you're using TCP, you gotta send a sync signal. Say, hello, are you there? The receiver has to send you an acknowledgement, and you have to acknowledge that acknowledgement. That's creating that's called connection oriented. You have an open connection now, right? When he sends you an acknowledgement, there's an open, he is ready and his connection is open to receive data. So what I could do as an attack, please write this down, those bullet points, the sync flood attack. So I can actually send a sync signal from bogus IP addresses, a whole bunch of sync signals to the web server, right? Because the web is using HTTP and HTTP uses TCP. So I try to make a connection from different IP addresses. And this guy sends acknowledgments to everybody that called him. But I don't respond. I don't acknowledge that. I'll just leave these open sessions. He opens sessions for me to talk to him. But nobody is sending data. This is like a whole bunch of people calling you, and you say, hello, hello, hello. You have your phone off the hook, and you have the session open, and nobody now can call you, right? Because you're trying to talk to somebody that's not even there, and somebody else, your friend, is trying to call you, but your phone is busy. He's getting a busy signal. That's what TCP Flood Attack does. You can use the reset attack. Remember that label in there? You can say, hey, this is the final. You can send the final fin segment to tell the destination, hey, I no longer have segments to send you. He sends you back an acknowledgement. He can send you a fin, and you acknowledge that fin, and then the session is ending, right? So you could actually hijack a session, send the fin, and this guy will end this connection. So when you do a session hijacking, you can get in there and do a reset attack by sending a fin segment. So please write that down. The first 3 bullet points is good enough for the reset attack. Session hijacking, we just talked about that. You can actually break into a session where it's already been a session that is active. Just remember, please write this down, that if it is successful and you were able to get in there, you could send data, but you're not going to receive, right? But that's still a vulnerability. All right, now let's take a look at the UDP segment headers. A lot less labels, only 8 bytes, as you can see. You only have the port number, the source port, the destination port, checksum to make sure that the data is okay, and the length of the data that's in there. So much less labels than what TCP has. It's connectionless. It's unreliable. Unreliable does not mean that the data It's not guaranteed. It just doesn't tell you that the data has been received successfully. That's what that means. They don't control the flow of the data, but it's fast. You're sending data extremely fast. So we love to use it for mainly DNS, DHCP, TFTP, NFS, and SMP. All of these protocols are typically within the local area network. You're not going outside, because if you're going to go outside, most likely you will use TCP. But UDP is preferable to use when you are using, is the preferred method to use if you're going for streaming video. So there are other protocols that will be added for reliability and to make sure that the data get there and reassembled correctly, because you're going to have to leave your LAN when you're doing voice over IP, for example, or streaming videos or things like that. Okay. All right, so UDP attacks. Just remember, right? Type the 2 bullet points. UDP doesn't come by encryption. It's not protected by encryption whatsoever. So all these segments are unencrypted, and they need to be encrypted if otherwise. Otherwise, the labels and all the data that's in there, maybe the session layer will encrypt the data, but the labels that are on that UDP segment are not encrypted at all, and everybody will be able to see them. All right. You can use unicorn, low orbit ion cannon to create DHCP attacks using UDP segments. All right, and that's it for Module 16. So please write down all these notes that I asked you to, and I'll see you on the next module.